First of all, how do I import the pandas? Just like NumPy, right? So I am going to import pandas. Case sensitive again, pandas as PD. You can give any name, but PD is what followed universally. So let's stick with that. Let's not try to manipulate there. So PD means it's a pandas. So import pandas as PD. So I'm using a NumPy also. For some reason, we will see that. Okay. So now onwards, what happens? Now, whatever we learned in a Python, whatever we learned in the NumPy, so we are going to use that, and we'll plug in this Python concept and a NumPy in the pandas. Right? Collectively, we are going to learn. Let's look into that one by one. First, import the library, pandas library. So in pandas, there are two structures here. One is a series. Second one is data frame. Data frame. What is series and what is data frame? We'll discuss one by one. So series, case sensitive, capital S. In the data frame, D caps, F caps. And it is continuous. There is no gap in between data and frame. So if I talk about a series will have one column. Series will have only one column. Data frame can have more than one column. So first we'll create the series and we'll try to see how it looks like, the structure of the series. So how to create the pandas series? I have imported pandas. Let's use that PD dot series. So it's just like a layman term, series of data, series of products, series of items, right? So series. So it's an empty series. And if I print that, there is nothing because I don't have any data as of now. Right? So this is an empty series, how to create empty series. So now we will add some data. Add some data and create the series. So pandas dot series, parenthesis, in that I am passing a list of numbers. Series can hold any type of data. Right? It doesn't mean that only numbers. Pandas is not only numbers. It can hold any type of data. Now I'm passing a list of data 0, 10, 20, and up to 90. And I will convert this list of data into series. How? Using pandas.series and storing this and print it. So it is generating such type of a structure. Now you can understand that this data is interpreted very nicely. And important thing you need to notice here, this guy. All the time we were discussing about indexes. So in the pandas, it is going to generate or it is going to create the indexes for each and every element. These are all the elements, right? For this element, for each and every element, it is going to assign the indexes. In the NumPy, in the list, in other topics, what we discussed earlier, we always try to assume that, okay, this is a 0, this is 1, 2, 3, and all. Behind the scene, it was taking this index. But when it comes to pandas, directly we can see what is the index for any data here. How cool is that? Even if we generate millions and billions of data, even the file is contains that kind of a data. So yes, pandas will give or assign that index, and you can see that right in front of you. So you don't need to worry about what is the index for somewhere around 2,39,340. We don't know that. So you will be able to find that index right there. And as I mentioned, index always starts from 0 and you can see that. And a series will have only one column. So this is not a column. Don't interpret it very wrongly. So this is the index. And this is basically what it. And the cool thing is you can change the index names, index numbers. You can give your name. You can give anything. We will see one by one. It's not only numbers. You can have a different data there. Your name, subject, age, profession, anything. You will be able to reset it. Those are advanced topics. We'll talk one by one. Let's start with the basics. So yes, this is about series. Let's check whether it is going to accommodate different data type. I have a 20, 15.7 and 10, right? So if I execute, yes, it is going to accommodate 20, 15.7 and 10. That is fine. Now what we will do, this is about what? Series, right? Series is very simple because it will have only one column. There is nothing much about to talk. So now let's try to understand the data frame, which is the most topic or the, I would say, format that we are going to do. Our entire data science is all depends upon this data frame. So we are going to save 99% of our data in the data frame. We hardly use the series. We use the series for some reasons. I will talk about that. So if I want to highlight, basically we use the series when it comes to time series problems, to solve any time series problems like a stock prediction, corona case prediction and things like that. So that is again, it's a part of a time series. Okay, so there people use this series data type, series kind of a format. So now we are focusing, our focus is on data frame. Now let's try to understand data frame. So here I am creating a dictionary, right? So we have this dictionary we discussed in the Python itself. I am using the same concept. I'm not changing anything, creating a dictionary, right? Let's create it. I'm not going into the Python basics, assuming that you have already gone through and well versed with the previous classes. So dictionary, now what I will do, I will take this dictionary. I will take this dictionary and I will convert that into data. How? Using pandas dot data frame. Again, case sensitive, I'm repeating. So I'm saying take a dictionary and convert that into data frame and put it in a one variable. So this is a df. You can give any name. Since we are dealing with a data frame, I'm just giving a shortcut, df, data frame, right? So let's execute this. Now you can see the beautiful structure, right? So you can interpret the data the way you want. Columns ABC, column names are there, the indexes, and 0th index 151, first index, second index, column A data, column B data, column C data. How cool is that? Right? Column C data 1, 2, 3, you see 1, 2, 3. So just by using pandas.data. So yeah, here we have created our own data. Going forward, we will use some files here. We will use some files and you will see the beautiful frames. Right, next upcoming topic. So this is basically what? This is data frame. Data frame. I can also call it as a data set. So whenever I say data set or a data frame, both are same. Don't get confused. Depending upon the situation, I can call data set or a data frame, right? But irrespective of what I use, it's all about the data frame. Okay. Now we have created a very simple data frame using some data, which is created in the form of a dictionary and converted into data frame. Now we'll try to extend our conversation on the data frame. Suppose I wanted to create one more column within the data frame or the existing data frame, say states. So do I need to go back here and say states, then again give the names? It's hectic, right? So I don't want to do that. So what I'm going to do, I am going to add a new column saying this is our data frame. Let me take this here, data frame. How to create a new column or how to add a new column. So take your existing data frame, then in the square bracket, not in the parenthesis, in the square bracket, your column name in the quotes. I will say states. Any column name you want to create, your choice. The syntax you have to follow is data frame and square bracket, and if it's a name, yes, it has to be inside the quotes because it is string. Okay, so I'm going to create a column name here, but how about this data here, right? I need a data as well. So manually, if you want to add a data manually, there are different ways. The very first, I'm just giving a simple way here. Suppose say CA, there is a space NV, there is a space AZ. So basically these are the United States USA states. This is a California, Nevada and Arizona, right? So I'm going to add CA, NV, AZ. So I'm using a dot split method here. What it does, by default, it will check the space. So until it finds the space, it will consider that is one data. Okay, this is one data and it finds the space. Take this data and write it. Then it will find the next data until it finds the space. Then again it will take and write into the next line. Same thing, next line. So this dot split method will identify the space. Based on that, it will write the data. Since we already know there are 3 rows, so we have 3 states. So this is a simple way of adding a data. There are different ways. We will see that as well. So now let's print the data frame and see how it looks. Yes, we have added a new column with the data. Whatever we want to add, you can add it. So this is basically how to create or add new column. Now, let's create one more data frame with different example. So here, I have a variety of data here. A, column B and column C. So what we will do, we'll create the data frame, then we'll interpret, because I want to discuss about this np.nan, right? Let's create this first. Now what I am going to do, I'll take this dictionary data and convert that into data frame and keep it in one variable df, right? Just like how we did in the previous example. Let's execute this. So this is how it's looking. Now there is something that we need to look into, that is NAN, NAN, NAN. What is this NAN? So it is a short form of not a number, not a number. What is this exactly? How do I interpret this? First of all, how did I write? Because I am using this numpy. In the A column, 1, 2, 1, 2 is there. After that, the third number is np.nan. So it is going to give this kind of a name. Let's try to understand what is NAN. Then the idea behind this NAN will be clear. Suppose say that you are filling the form, online form, for any competitive exam, or maybe say that for any membership, say that any mall membership or a big bazaar membership or anything online form, you are filling it up online form. There you are asked to write a name, phone number, email, right? Big bazaar membership. So you will write your name, you will write your email ID, but you don't want to give the phone number, right? Most of us, we don't give in a public or I would say any online when we are filling, right? We don't want to give our personal, we don't want to get disturbed, right, by calls and things like that. So what I will do, I will not fill anything here. I'll just leave blank and I will submit. So what happens? Name will be stored. Suppose a name XYZ. This is the phone and this email. Email will be filled with what? Some xyz@gmail.com. Since you did not fill anything, so how it is going to store the data? So it is going to store something like this, NAN, not a number. Because when you submit this, behind the scene, it will store somewhere, right? Maybe database or in the file or wherever, it depends upon the company. So when it stores, it will store like NAN. It means that user did not enter any data. You don't know whether data is there or not. So he did not enter anything. So that kind of a data will be stored something like this, NAN. So if I have this kind of a data, what I should do? Because my whole purpose is to get the user phone number so that I can call them and explain the benefits about the membership and also that they can get enrolled and they get the benefit and he gets the some points or whatever it is, depending upon the business. When user did not enter the phone number, then it is very difficult, right? It's very difficult to communicate through email. He can send a mail, but if you want, you will reply. Otherwise, you don't reply. But when it comes to phone, somebody calls you, whether I definitely will say something, yes or no, or whatever it is. So when we have this kind of a data, so there is always possibility that we can fill this data. I'm just taking a phone number example. It could be your age, it could be your experience, it could be your email, your location for different business, right? So basically that is what is the NAN. When you don't know the data, which is filled without any entering any type of a data, so that kind of a data we can treat it as a NAN. So manually I'm trying to create NAN data here. This is for the B column, right? NAN and NAN, because 2 NAN, not a number, which is very important in our data science and most important, you need to focus more on the NAN because these are very important in the interview as well, right? Most of the interviews will not finish without discussing on this NAN. We will deal with this NAN many number of times. All right. Now, let's create one more column here. DF, this is our data frame. Let's create a D. And how many rows? 3. So 20, 30, and 40. So yeah, this is one more way of adding a data to the new column. Earlier we used a text and say dot split. Now I'm using directly integers for this new column. Yes, that also we can do. Okay. That's a simple data frame creation and adding a new column. Now let's say user did not give the phone number. Then what is the use of keeping user data? Just think that this angle, from this angle, suppose say I want user phone number so that I can call and explain the benefits about the membership and things like that. When user himself or herself did not give the phone number, right? So then there is no point of keeping user details. What the company will do or the big bazaar will do by knowing your name. Your name can be XYZ. It is not going to help them. Your date of birth can be anything. It is not going to help them. Right? So all they need is phone number so that you can listen. When you are not giving a phone number, then they don't keep your data. They will throw it. So in that case, suppose say these are the phone numbers. Let's assume that you did not give, then why should I keep your data? I have to delete. Right? So when I'm deleting it, so your name, your location, your salary, date of birth, anything, gender, I don't want anything. So what I'm going to do, I'm going to drop them. Drop is simply nothing but delete. All the data. This is a name. This is a name. This is a phone number. This is email. This is a location. This is age. This is date of birth. You have 10, 15 columns data. When phone number itself is not there, I don't want this entire details. So I will simply delete this. So how I am going to drop it? So there are methods. So this is our data frame df dot drop na. Drop na. Right? So I can delete the data row wise. I can delete the data column wise. However I want, I can delete it. So let's try to delete one by one. So let's try to delete column wise. So df dot drop na. It will identify all the NAs. So here I'm giving one parameter, axis equal to 1. In this case, axis equal to 1 means, so wherever you find the NANs, just go ahead and delete column wise. So in the A, it has NAN, so the whole column is deleted or dropped. In the B column, we have NANs, it drops B. So leftovers are C and D. So that is what we are seeing here. So these indexes will never change unless we change it. So I will talk more about this, but yes, index numbers will present. It will not go away because otherwise it is difficult to identify which index and things like that. So yes, axis equal to means 1 means drop column wise. Column wise. If I want to drop row wise, yes, axis equal to 0. So let's see that one. So even though you don't mention axis equal to 1, sorry, axis equal to 0, still it will be row wise by default. So axis equal to 0 is for the row wise. Even if you don't give also, it will delete row wise only or drop row wise only. This is our data set, data frame. Now you may be wondering that yes, we have dropped here and we saw only C and D columns. Then when we print again, why it is showing all the rows, all the columns? It is because we haven't saved the data. This is going to show you that if you perform this action, this is your result. That is the beauty here. If you perform this kind of action, this is your result. Once you satisfy with your result, later we can go ahead and save it. How to save and all, I will talk about that later, not now. Right? Because humans, we make mistakes, right? So we assume that this method is good, this method is correct. And by mistake, if you do any mistake, right? So you cannot revert it back again. Again, you have to start from the scratch, which is headache. So yes, we have some parameters to save the data frame. So here, this is all temporary and it will show you. This is the result you will get for this action. After that, if you print, you will get the whole data. Right? So that is what it is. And I will talk about how to save. This is a simple parameter we need to add. We will see that going forward. Now this is a data frame. So drop NA, let me repeat once again. DF, this is your DF, dot drop NA. Drop NA. So here I'm giving access equal to 0. So if I say access equal to 0, now you will see here we have NaN, this whole row will be deleted. Here we have NaN, doesn't matter, 2 rows either here or here, even one, if it finds one NaN in this entire row, so the whole row will be deleted. So this is the only guy left. So that is what we are seeing. Right? So that is row wise deleting the row, data based on NaN using some methods. A method is drop NA. And the original data frame remains the same. Until we save it, it will remain same. There are different ways of saving. We'll talk one by one. All right. Now, we know how to delete row wise and column wise, which is fine. Now, I don't want to delete this. I don't want to delete this. I want it to fill with some number. Fill with some number, some data. Fill it something. And this also fill with something. Deleting is always not the solution, right? So there are situations we have to deal with that one. We have to add some data to that wherever I see an NaN. Say phone number. Phone number did not, user did not fill the phone number first. Later, maybe you collected that phone number from the user through email exchange, saying that, sir, you have not given your phone number. Could you please send your phone number so that we can call and explain the benefits? The real user, the real person who really interested to enroll for that program or membership, he will reply and say that this is my phone number. So then I can take that phone number and fill it here. Similarly, age, experience, whatever. I'm just taking a phone number example. In real time, there are thousands of use cases, thousands of projects in different projects, different data missing, right? So yes, there should be some way of filling the data. So there comes fill NA. Fill NA. So your data frame, whatever the name you have given to this, use that, then fill NA. Okay, I am going to fill it. It will point to all the NaNs. What is the data? Then I will say value is one of the parameter. Which value you want to fill? I will say 50. I will say 50. You fill this 50 to all the NaNs. So let's execute this. And here you can see this spot, this and this, you will see all those filled with number which we have assigned. So value is the parameter. Even if you don't give value, even if you say only 50, it will fill with a 50. This is the parameter value. And how do I know that? Yes, same concept. Just keep your cursor and press Shift Tab. You will get different parameters. We will discuss these parameters one by one later, right? One by one. We already discussed axis. Now we are discussing value. We'll also discuss different things. So this is basically what? Filling the value, filling the NANs. Wherever NAN, you fill with some number. So, but there are questions like how can we fill the same phone number if you convert this example to phone number? How can we give the same phone number to different people, right? Obvious. So yes, those are all the concepts we are going to learn, how to fill exact data into the right column, right data into the right column or a right row. So yes, we have various techniques to do this. In the upcoming videos, we will see that, right? So now, data frame. So let's keep this data frame. Now, I wanted to fill some data here. This is getting interesting now. Now you see this df.fillNA, which is exactly what we discussed. Now value, what we did value here in this case, we just filled 50, right? So now I don't want to fill value just like that, 50. So what I want, look into this, df of C. When I say df of C, it is going to select, if this column exists, it will select that, okay? df of C dot mean. Mean is nothing but average. Average of what? C column. What is the C column? 1 plus 2 plus 3. Average is what? Sum of all the data divided by number of elements. How many elements? 3. Right? 6 by 3. 2. So what I'm saying, select this column C and take an average. That average is basically what? My value. You see, things are getting interesting. Because how do I fill this 50 here? Because I don't know whether it is making sense or not. Suppose say that this 1, 2, 3 some marks out of what? Out of 5. Right? Out of 5. How can I fill 50 there? How can I fill 100 there? So I wanted to select some data within the data frame and apply some logic so that my marks will stay within this 5 only. Right? So that is what I'm trying to do here. Select the C column and take a mean out of it. And that is basically what? My value equal to 2. It happens, it is like a value equal to 2. Fill this 2 in wherever you have an A. So now, the new parameter, in place equal to true. In place equal to true. I will write it in place equal to true. What does this do? It is going to save your data set. Save the data permanently. When I say permanently, so until you change it, it will remain in the same position, or I would sorry, in the it will have the same data until you change it. So now let's go ahead. Right. So let's print this. Now you can see 2, 2 and 2. 2, 2, 2. So that is basically what? With this, we were able to fill the data. So if we take a C column and take a mean out of it, so it will be 2, and those 2 will be filled wherever we have ended. Right? So that is the idea behind this particular logic. We can use different logic. We'll talk about that. And in place true is basically to save your data. So anytime you print df, you will get the same this data set. You will never get now any error until you change the data or until you assign something new data to the same name.